All right, so this question asks us to determine if the graph is symmetric about the x-axis, the y-axis, or the origin, or the equation r equals 2 cos 5 theta. So there's 3 tests that you need to do to determine if it's symmetric on the x-axis and y-axis and the origin. And these tests are as follows. So test for symmetry on the x-axis, we'd have to figure out if we substitute theta into the equation r, and we substitute negative theta, these two must be equivalent for symmetry to occur on the x-axis. The other situation that we could also solve for that would give us symmetry on the x-axis is negative r theta should equal r pi minus theta. So this is the other situation that you can substitute in. So this one might be easier because it's just substituting in a negative value for theta. So this is for x. For y, for symmetry on y, we would substitute r into theta and theta into r, and then we would substitute r pi minus theta. So here we have r theta has to be equal to r pi minus theta. If we substitute pi minus theta into the equation, these two have to be equivalent for us to get y-axis symmetry. The other scenario that they have to be equivalent to is, not have to be, but one of them has to be true. And one of these two equations has to be true for symmetry on the y-axis is negative r negative theta. So this is the other equation that we can use to test. So we're going to be using this equation to test for the above. And then finally, the origin. We would test for r theta is equal to r theta plus pi. Or we could also test for r theta is equal to negative r theta. Okay, so these are what we want to test for to determine if it's x-axis symmetry, y-axis symmetry, or origin symmetry. So we're going to erase all this to make some space. Okay, so we'll start off with y-axis symmetry. So if we had r theta, we would just get the above equation. And then if we had negative theta, we would get 2 cos negative 5 theta. So here we want to think about the cos value. The cos are components. So we know that cos of a negative theta is equal to, so let me just write this side by side. Cos negative theta is equal to cos theta. So this is just a definition of cos theta. So cos negative theta will equal cos theta. So knowing this, we know that therefore this must equal to 2 cos 5 theta. And therefore, because r negative theta equals r theta. Therefore, we have x-axis symmetry. Okay, so we tested for it the first case, and we know that we have x-axis symmetry. So here, I'll just make a little legend and we'll say x check mark. And then the second scenario we want to test for is y-axis symmetry. So here we want to test, so we know r theta will equal this. So r pi minus theta will equal 2 cos pi minus 5 theta. So here we can see that we can't really simplify this easily to get kind of both sides to be equivalent. We could try to expand this out, but we can kind of make a judgment call here, and you can see that this can't be really simplified into 5 theta because we have the extra 5 pi term here, so we know that there's no y-axis symmetry. So there's no y-axis symmetry. We only have x-axis symmetry so far. And the last thing we want to do is symmetry around the origin. So symmetry around the origin is r theta has to be equivalent to r theta plus pi. So we know that if we substitute into theta plus pi, so the simpler way to look at this, if we're substituting into the cos term, so we really only care about if cos is equals to cos theta. So this is kind of what we're looking at. So when we substitute r into theta plus pi, we would get 5 times theta plus pi. But here we really only care about this term. So this would be equal to, because if we have the pi term, it would equal negative cos theta. And that's really how I should have tested for the y-axis symmetry as well. So because it's equal to negative cos theta and not cos theta, that's why we get the no y-axis symmetry and no origin symmetry. So even if we substitute for pi, for testing for the y-axis, for theta minus pi, we'd still get negative cos theta. Oh, sorry, this is a little messy. So we still get negative cos theta for both the y-axis, so this is the y-axis symmetry test, and then this is the origin symmetry test. We can include the 2 in the front, but 2 doesn't really affect it, and the 5 also doesn't affect it, so really we only really care about the angle in the cos component, and we know that it's only for x-axis symmetry. So here we only observe x-axis symmetry for the presented equation. So just looking at this solution a little more thoroughly. So x-axis then is satisfies condition, so it's correct. They test for this condition. So here, yeah, they ignored the 5 and the 2. You only really care about the cos negative theta to get cos theta. So you know that r theta equals r negative theta, and you have x-axis symmetry. And then they test for the y condition. So similar idea here. We have pi minus theta substituted in, and you only really care about the cos component in the angle. And then this would give you negative cos theta, which means it's not equivalent. The two terms r theta and r pi minus theta are not equivalent. And then similarly here, same idea, we're only really focusing on the cos component, and you get a negative cos. So solution is correct.